Good morning, everyone. So my name is Catherine Stanford-Edwards, and I'm going to be talking about circularity of equipment, but very specifically, not sure if you can quite make it out, X-ray producing medical equipment. So I work in Swansea Bay University Health Board, and I work in Singleton Hospital, which is shown here just next to the beach, which is lovely. And I'm a radiotherapy physicist, and my main role is I'm a lead for dosimetry and QC equipment. Now, a lot of you might be wondering what on earth radiotherapy is, might not have that much awareness of it. So I'll give a bit of a background to the type of equipment that I'm talking about. So external beam radiotherapy is the area that I work in, and this is a form of cancer treatment that's used in about 50% of all patients' treatments for cancer. And what it does is it aims very high energy radiation at cancer using a machine called a linear accelerator, which is shown here in this picture. So from the head of the machine, really high energy radiation comes out, directed at a patient laying on the couch, and the whole machine rotates around and it's very targeted. And the idea is that the ionizations from this high energy radiation destroy the cancer cells and shrink tumours. So this is the type of equipment that I'm talking about. Now, during my cake journey, I knew quite early on that I wanted to focus on what I could do within my workplace. So I wanted to figure out how I could implement circular economy principles into my organisation for equipment management of this sort of equipment. So I've got shown here the linear accelerator that I had in the previous slide used for treatment. And I've also got a CT scanner because we have to personalise each patient's treatment by taking a CT image first off. So these are the type of X-ray producing equipment that I'm talking about. Now, has anyone got any idea of the cost of these sorts of bits of kit? Any ideas? A lot, yeah, it is a lot. Yeah, so a linear accelerator costs about £2 to £3 million, and that's not including the building work around it. It uses a lot of concrete for shielding, which is a whole other battle, but yeah. And a CT scanner is about 600k. They're very expensive bits of kit. Typically, their lifespan is about 10 to 12 years. And this is because we want to limit breakdowns, we don't want to affect patients' treatment. But also, if over time things progress, we don't want to not offer the best quality treatment to our patients as well. So 10 to 12 years for that several £1 million bit of kit. So, focusing on the linear accelerator, this is that treatment machine with its gantry rotated round. So you've actually got the head where the radiation comes out sitting on the floor here. And this is it with its covers off. And as you can see, there's an awful lot going on inside of it. There's lots of parts, lots of pieces of equipment that basically need maintenance. We don't want to delay any patient's treatment, so we have preventative maintenance schedules that happen. We replace some of these parts regularly because we know they'll break. Things do break anyway, we need to replace them, and the parts themselves can cost thousands of pounds as well. So that's the sort of picture that I had, the situation I was in. So on my cake journey, my challenge or problem statement was how might we reduce valuable and reusable resources going to landfill, such as some of those parts from the machines, integrating the circular economy within our organisation, so values added to some of that equipment as well. But of course, we need to take into account patient safety all as part of that. That's at the forefront of it all. And obviously, there'll be policies and regulations around that as well. But whatever we do, we want to make sure that it's safe. To do this, it's quite a big challenge. And quite early on, I realised I needed to get links between procurement, manufacturers and users of this sort of equipment. So my journey, initially with Cake, it was like, got to empathise, let's engage with stakeholders, figure out what our options are, what could my challenge actually look like. So as part of this stakeholder engagement, I spoke to other centres in the UK. So I've got a professional membership body called IPEM, the Institute of Physics and Engineering and Medicine, where I discussed with other people with like-minded views with me and in terms of sustainability, what options there were. I did an audit of all the suppliers of equipment to our department, mainly focusing on packaging at that point of view, because we were getting tiny items delivered with an awful lot of plastic around them in a giant box. So, and I sort of reviewed this and did an article in my professional magazine as well. But as part of that survey, it wasn't just about the packaging, it was asking the manufacturers or the suppliers, are they interested in sustainability? Have they considered this at all in terms of their policies and so on? So I got an idea of their viewpoints from that. I engaged with procurement in Swansea Bay University Health Board, and then that also led me on to dealing with procurement services across the whole of Wales, NHS Wales as well. Following that, feedback from all those engagement activities, ultimately I found that everyone was interested and aware on some level of sustainability. Very much in the early stages though, people didn't really know how to change their procedures, change their working to be more sustainable. Some people did hint at circularity, but again, very early stages. I think in the NHS Wales procurement policy, it mentions circularity, but in terms of how to implement that, very little guidance on it. So in terms of defining my challenge, it was very much we need some guidance on what people can do to implement circularity. There are sort of resources out there, different policies and things. So I've got here, there are policies, EU things on waste from electrical and electronic equipment. There's the Welsh procurement policy, which again talks about circularity. But a lot of users might be a bit hesitant about using repurposed, remanufactured things. But there is a BSI standard as well talking about circularity as well. So there's bits of sources of information out there to help define the guidance as well, or put it together. So I'm very much still in the ideation stage of my journey. So I've recently gotten in touch with a UK trade association of X-ray equipment manufacturers called X-ray. So they represent the companies in the UK who produce or manufacture this X-ray producing equipment. And I'm part of their working party to draft some guidelines on circularity, which will be fed back to their members to hopefully actually get some movement on that area so that manufacturers will know how they can act more circular. But with that, I need to pull in information from finance, procurement, and obviously there might be legal implications around this as well. So it's very much in that early stage, pulling that all together. Something more recently that's happened closer to the end of my cake journey is, although I'm continuing this work with AXREM, I have linked in with a previous member of CAKE who's working on something very similar in NHS Wales procurement services. And I'm going to take part in some roundtable events that they're having with other suppliers through the Association of British Health Tech Industries as well. So as a summary of my CAKE journey, I learned a lot on the programme, defined a challenge, did some stakeholder engagement and mapping, and certainly learned a lot. Then in terms of applying that knowledge, I've engaged with different people in my organisation, also regionally in terms of NHS Wales procurement, and then nationally with this AXREM trade association. And I'm hoping all of this will help to influence policy through having these guidelines to influence manufacturers. This then might lead into updating some things in NHS Wales procurement policies, and possibly even our next purchase of one of our linear accelerators or CT scanners, we might be able to get something about circularity, especially at the end of life of the equipment, or reusing parts and things like that, or refurbishing parts. Thank you very much for listening, and that is the end of my talk. Thank you.